Our task is reconstruction of 4D dynamic human within a 3D large-scale outdoor scene. Our input is a RGB video photographed by a drone circling a human. First, we reconstruct the 3D background scene and render a novel viewpoint. We also optimize 3D human mesh and visualize consistent SMPL on the 3D point cloud. Then we utilize the SMPL mesh to reconstruct and render the 4D dynamic human performing kicking frame by frame. We can display novel view rendering after reconstruction. Also, at the kicking moment, we display our 360 degrees free viewpoint rendering result, like the bullet time effect in the movie.
Our task is 4D reconstruction of sports scenes from a monocular RGB video. This task is challenging as the viewpoints are rather limited in real outdoor sports. Existing systems either rely on multi-view or merely provide limited viewing angles for rendering. Besides, the human is confined in a limited space. We proposed a novel drone-based system that can autonomously track and orbit around the athlete, providing 360-degree novel view rendering of the entire sports scene. Given a drone video, we first solve the camera poses by our DMC calibration module. Then we utilize our DSM module to estimate per frame human SMPL under the world coordinate, as well as the 3D bounding box. Then we adopt a layered representation based on the bounding box, which help us to train the background model and human model together, enabling compositional volume rendering. Here is how it works. The 3D bounding box is a spatial clue to divide the 3D space into two parts, the inside space and the outside space. During training, when a ray intersect with the bounding box, the inside sample points will be used for training the human model, the other points will be used for training the background model. Then the network outputs are compassed together in traditional volume rendering to get the final pixel color in rendered novel view image.
As we illustrated, using one drone is enough for our pipeline. However, we use altogether 4 drones for data collection. We use 2 for automatically orbiting and 2 for handheld, and will compare them using the same pipeline algorithm. In practice, we use a movie clapstick for manual time synchronization of the 4 drones. Here is the illustration of using 4 drones for collecting data cooperatively. We render 360 degrees free viewpoint videos with depth map to evaluate the 3D scene reconstruction, and our drone-based method outperforms the handheld one with more detailed reconstruction and smoother depth. In human reconstruction, due to the limited observation angles using handheld method, it fails to reconstruct human completely, and some parts of the human could contain the background color during rendering. Motion capture results. And more 360 degrees free viewpoint results using drone. Thanks to the virtue of the monocular RGB-only system, our method can also handle internet drone videos. We collected over 100 clips of outdoor extreme sports videos for all. Here is an example. We are able to reconstruction and rendering from an internet diving video, and we can perform video editing like removing the athlete from the scene.